What's up, guys? We're back with day 6 of Advent of Code 2023. Today was probably the easiest day by far, so far, but let's go over the solution real quick. Before that, I'll explain a little bit about the rules. So, this example input is basically the entire input, it's just two lines. The first line lists a bunch of times, the second line lists a bunch of distances, and what we're doing here is we've got some little toy boat, and the longer we hold it down, so this goes back to the time, the longer we hold it down, the faster it's going to move. But there's some total time limit. This is actually the time limit for the whole race. So the longer you hold it down, the faster it's going to move, but the less time it has to move. So we're told that the second row, the distances, are the record distances, and we need to try to beat the record. So basically, we're just looking for the optimal amount of time to hold down the button so that we can exceed this distance. And sounds pretty straightforward, and it really is. So let's hop over to the code and take a look. Here you can see we're back in AWK today. I did have a close call with part 2 where I thought I was going to have to brute force it with Rust again, but we were able to stick with AWK through the whole day. So you'll see I've just got this empty pattern at the top that's going to print all of our input lines. And as I was mentioning with the problem description, we parse the timeline into an array of times, we parse the distance line into an array of distances, and then we move into our end block where we do all of our processing. So because the scoring system for today asks us to take the product of all of the numbers of ways that we can beat the distance, this is obviously an important part of the rules I forgot to mention, that we're not just looking for, one of the ways that we could beat the distance. There are usually several or many different ways we could beat the record distance. So we're supposed to count the number of ways we can do that. That's why I call this function count. We'll talk about that in a second. And to get our final score that we put in our input box, we just take the product of all of those counts. So now that I've said it in words, hopefully the code flows pretty clearly from there. We initialize our product to 1, unlike a sum, which you usually initialize to 0. For products, you want to multiply by the identity, which is 1 rather than 0. So we just loop over our number of fields. And this might look a little bit weird because in the end block, there are no fields. We're past the last line, but it remembers the number of fields from the last line of the input. So we're safe to use NF here. We can set C to count, where I just pass in the time and the distance. And I'm also printing it out, so you'll get to see what some of that looks like. And if it's not 0, we multiply our product by it. And at the very end, we print the product. So clearly, most of the work is done in the count function, which I've added some nice comments to. In line with the problem description, it's just going to return the number of ways to beat distance. And I've even explained what some of the variables are. Probably would have been better to name them something more descriptive, but anyway, I started off with I, and I stuck with it. So you can see here, I is the number of seconds we held down the button, skipping both the hold time and 0. So if you don't hold it down at all, obviously, this is a tiny optimization where I'm cutting off like 2 of the digits, and some of the times can be quite large, but anything potentially helps. So I went ahead and skipped both of those because, as I was saying, if you hold it down for 0, your speed is going to be 0, so you're not going to go anywhere. And if you hold it down the whole time, you'll have no time left to actually move. So I skipped both of those by going from time -1 to time greater than 0. And I'm looping in reverse, but it doesn't really matter. And then down here, we do a tiny bit of dimensional analysis where we set our value to time minus I. So again, I is how long we hold down the button. And time is the total time. So time minus time holding the button gives us time moving. And the distance we get is speed times time. So that's our formula. And if it's greater than distance, we add 1 to our counter, and then we return that. So great, there we go. I can just hit F5 and run that on the input. And this should give us our correct answer along with some of the input along the way, or the output along the way. So with that, let's go ahead and move on to part 2. Here we're back at the rules again. You can see that the input, of course, is still the same, but instead of parsing these as individual components, we now just glue all of the things together. And this is where I thought the brute force is going to come in. This is obviously a much larger number, so is this. But as you'll see in just a second, it's actually still manageable to do it with just the naive implementation. So let's hop back over to the code and see what it looks like. Here you can see that I've got the diff pulled up again, just so you can really draw it, just to really draw the attention to the differences. You'll see that the code actually kind of got shorter, especially down here, and simpler, I guess. So here, instead of accumulating the times into an array, you'll see that now we're using our classic string concatenation and awk by putting the current time next to the next element. So this just puts them together in time, and the same thing with distance. Then when we get down here, and we don't even need a loop anymore, we just call count on int time and int distance. I did have to add these ints or it was not running correctly. Probably because when we did the string concatenation, that caused awk to interpret them as strings. But anyway, once we cast them the right type, print C. This takes about 5 seconds to run. We can watch it go. There's one. There you go, 5.7 seconds, we got our answer. So brute force wins another day. Now, just because that was so fast, I do have one other trick to show you guys. And this sped it up by about, not quite 50%, but I guess 30, 40%. It dropped the runtime down to 3 point something seconds. But because we know, when I was reading the problem description, this sounded a lot like the binomial distribution to me. I thought we were going to be doing like some n choose k or something like that. But if you're very familiar with that kind of distribution, you'll know that it's symmetrical. So at the lower end of the wins, we get the same numbers as we get at the upper end. So using that observation, we can actually cut our search space in half, and we can keep this counter j in addition to our counter I. And so instead of checking if I is greater than 0, we can check if it's greater than j and increment j on each iteration. And then the only change we have there is that we have to double count each time we get it. So there's just a minor optimization taking advantage of this symmetry. And you can see if I run it again, it should take about 3.5 seconds. Yep, there you go. And it should give us the same answer. So with that, I guess I'll leave it off today and see you guys tomorrow, hopefully. I'm kind of scared about tomorrow. It seems like the odd days are more challenging. But anyway, thanks for watching and see you tomorrow.